Well, hi everybody. I hope that you had a wonderful spring break and it was a lot of fun and you're ready to get back in the swing of things. We are almost towards the end of school and we're getting ready to do some things called parametric equations, and they are going to allow us to show motion and to show more of a story whenever we're graphing things than the static things that we've drawn before. What I mean by static, if I just draw you a picture of a graph and it's just sitting there, then you don't know how it was drawn unless you actually saw me draw it. If I just have this graph like this, you know that I went from left to right because you watched it, but if you came back later, you don't know that I was actually traveling along this path. And so what we do is we introduce something called a parameter, typically that's t for time, that's going to show us more of a story. So let's get started with parametric equations and the basics here. So let me grab a hold of my car here, and let's see if I can, to show you this picture of this car moving along this path and in which direction it's going, we need a parametric equation to do that. So that's enough of that prop. Let's get started with this. Okay, you are going to have, with parametric equations, you are going to have x of t and y of t. So both x and y are going to be found by using a third variable. We call that the parameter, and it's almost always t for time. So here, this is x of t equals 3t squared and y of t equals 2t, and I have a restricted domain, and my domain is -2 to 2, and we're going to actually let it be equal to both of those. So let's make a little table of values here. My variable t, okay, we're not doing that. That was horrible. Let me get to my eraser. I'm out of practice. Okay, and then we'll go back here to my lines. Yeah, I like this better. So I'm going to have variable t. I need to make space for x and y. Okay, and I'll go across like this too. I like it. I like it. Okay, so and then I'm going to have my x coordinate and I'm going to have my y coordinate. So we're going to have t going from -2 to 2, and we're going to get our x coordinate by plugging those values for t into this x equation, 3t squared. So if you take -2 and you square it, you get +4 times 3 is 12. And then for the y coordinate, you plug in -2 into the y equation. So that would be 2 times -2, which is -4. And there's our first point, 12, -4. So I've got like an x and a y coordinate here. So I know we'll call that at time t equals -2, we're at a specific point. Now let's do the same thing with -1. Plug in -1 for t and you square it, you get +1. And times 3 is 3. And then -1 times 2 is -2. So we're at the point 3, -2. And if you plug in 0 for x of t, you're going to get 0. And if you plug in 0 for y of t, you're going to get 0. And we plug in a 1, we should get 3, and we'll get a 2 there. So I've got my points 0, 0, and then 3, 2. And then my last one is plugging in a 2. 2 squared is 4 times 3 is 12. And then plug in 2 for t there, we get 4. So we're at the ordered pair 12, 4. So let's take a look at this on our graphing calculator. What this has done is it gave me some specific points, and when we graph this, let me see if I can go actually grab a graph. Let's do that right here. Yeah. Okay. So when I graph this, let me get to my select. I'm really out of practice. There we go. So I've got 12, -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's be out there further. -4 is down here. And then 3, -2. And then 0, 0. And then 3, 2. And then back out there at 12, 4. Okay, so it'll be up here somewhere, right? Okay, so what I can do when I'm graphing this is I can show you the direction. So instead of just connecting these dots with a smooth curve, which I'm going to try and do here. I missed one. Sorry. I can actually show you direction. And this is the way we're going to indicate direction. We're going to put these little arrows so we know a third dimension. We know that the path was in that direction. Let me show you how to do this on your graphing calculator. On the graphing calculator, alright, you're going to go to mode, and you're going to change the mode to PAR. That stands for parametric. So down here in your mode, you're going to take it off a function and over there to parametric. And then when you hit y equals, you're going to have space for both equations, both your x equation and your y equation. And when you go to your window, you're going to have another thing to set, your Tmin, Tmax, and T-step. Now, of course, Tmin and Tmax was given to me. Your T-step is how many calculations you want your calculator to do. We did a total of 5. But if we just connected those 5 dots, it'd look pretty choppy. Let me show you what that looks like. So if I have a T-step of 1, it looks like, you see how choppy this is? Because it's only doing like, 5 dots. So you want your T-step to be pretty small. So I'm going to call that 0.1, and you get a lot smoother curve. Now your X-min, X-max, Y-min, and Y-max you can get from the table. So we can go here to the table and see when t was -2, I need to see out to the right 12 and down -4. And when t is -1, so you can get your left and right X-min, X-max, Y-min, and Y-max by looking at your table here. So that's why I have my window set like it is. On top of that, whenever we're graphing these, go back to my y equals, we can actually see what happens by changing this little thing all the way out here to the left. Let's change it to a connected little circle, and let's watch the graph. And so we can see what is happening. It's actually showing the path of the particle instead of just a simple graph. Okay, so let's go back here to this, and let's unparametricize these. I really don't know if that's a word, but it's called eliminate the parameter. And to eliminate the parameter, we are going to get this in like y as a function of x is what I want. Alright, I don't want to be there yet. So let me just extend this page. Alright, so I originally had x equals, what was that, 3t squared? And y equals 2t. So what we can do to eliminate the parameter is you can solve one of these equations for t. And I guess I'll just solve the y equation for t. So I'm going to divide both sides by 2, and I will get that t equals y over 2. And then we can take that and substitute it in here for t. So I would get x equals 3 times y over 2 squared, which is 3 times y squared over 4, which is, scoot over here, x equals 3/4 y squared. And from Algebra 2, you should know that that's a sideways parabola. And so that's called eliminating the parameter. You just take one equation and solve it for t, and then substitute that into the other one, and you can get it into what you're used to, x is a function of y, or y is a function of x. Okay, so let's go take a look at graphs, parametric graphs that have sines and cosines in them. And what I want to do here is I want to see what would this be a graph of. So we know that I could manipulate this and call this cosine t is equal to x over a, and I could multiply both sides by divide both sides by a on the other one, and I could get that y over a is equal to sine of t. Now we know that cosine squared plus sine squared always works out to be 1. So I'm going to substitute these in for this equation. So x over a squared plus y over a squared equals 1. And so I'll get x squared over a squared plus y squared over a squared equals 1. And then I'm going to multiply through by a squared, and I get the equation x squared plus y squared equals a squared. So I've eliminated the parameter here, and what do I have an equation of? Well, this is the equation of a circle centered at 0, 0 with a radius of a. So x equals a cosine t and y equals a sine t is going to be the equation of a circle. And with parametrics, you can actually graph a circle much easier than you could in function mode. And we'll be playing around with that as well. Okay, let's go take a look at an example of how to look at a graph and actually create parametric equations. And there's infinite answers to these. Let's start with the ordered pair 2, 0 and get to the point. I think that is 1, 2, oh, that's 7. Let me erase that. That's 7, 5. Okay. So, but we want to start at 2, 0 and we want to stop at 7, 5. So we're going to create equations for a line segment, but we want it to go in this direction, you know, like in this order. Now there are several ways to do this. One way we could do this is we could find the equation of this line. Like what if it was extended forever? And of course we know the equation of a line. Y minus y1 equals m times x minus x1. We can do it that way, or we can do y equals mx plus b. We can do it that way. I prefer the y equals mx plus b version. Let's find the slope of this line. This line is going up 5 over 5. So we know our slope is 1. So I can pick either one of these equations. Let's start with this 2, 0 here. The y coordinate is 0. My slope is 1. And so I solve this for b, and I get b equals negative 2. So that's the equation of the line. Y equals 1x minus 2. Let's write that again because that looks horrible. Y equals x minus 2 is that equation. But if I graph y equals x minus 2 on my graphing calculator, it's going to go on forever. So what I'm going to do, an easy way to do this is let x equal t. And then let y equal the function with t in it. So for this example, my equations would be x of t equals t, and y of t equals t minus 2. All I did is replace that x with t there. And then I would have to, I'd have to figure out what values for t would get me to 2, 0 and to 7, 5. For example, if I start with t equals 0, I'm going to be at the ordered pair 0, negative 2. And 0, negative 2 is not on that line segment. So what do I need to start t with? I need to start t with 2. And then what do I need to stop t with? Well, if I want to get out to x coordinate 7 and x of t is t, then I'm going to go from 2 to 7. Now, that's not the only answer to that. I could have also done x equals t plus 2. Now, why would I do t plus 2? Well, if I want t to be 0 and I want to start at x coordinate 2, so I could have the equation x equals t plus 2. Because if you plug in 0 for t, x is 2. And then y would be f of t. What we're going to do is we know that is the equation 1x minus 2. So what we're going to do is plug t plus 2 in for x, put a 1 in front of that, minus 2. You see I'm replacing this with my x, and so that gives me the equation y equals t. So here's another answer to that. X of t equals t plus 2, and y of t just equals t. And this would go from 0 to 5. Okay, so we're going to be playing around with parametric equations for a couple of days. Tomorrow you're just going to get used to the basics. This is just the basics here. And then later in this week we're going to look at some motion problems, which are actually pretty fun. It's a little physicsy, but if you like physics, I guess that's a good thing. So anyway, I will see you guys tomorrow.